In this lecture, we will learn what an interpolation search is and how to implement an interpolation search in Python. An interpolation search requires both that the collection is sorted and that the elements are uniformly distributed. Interpolation search is an improvement over a binary search because it doesn't always start in the middle. If it is looking for an element closer to the beginning, it will start closer to the beginning and vice versa. The only difference between a binary search and an interpolation search is the calculation of the probe position. The formula for calculating the probe position is the following formula. Here's the collection of example data that we will be using for this example. We will be searching for element 84. The first step is to calculate the position of the probe. This results in 5.6. The 0.6 gets chopped off, leaving us with 5 as the probe position. Therefore, the probe is 73, the element at index 5 in the collection. 84, the element we are searching for, is greater than the probe, 73. Per the algorithm, the low end will become the probe plus 1, meaning 84 is now both the low end and the probe. 101 will be the high end. Now we plug the new numbers into the formula and get 6, the exact index of 84, the element we are searching for. Now that we have a conceptual understanding of the interpolation search algorithm, let's write the Python code to implement the logic. We will use the def keyword and name our function interpolation search. It will take in two parameters, elements, which will be the list of elements we are searching through, and x, the element we are searching for. Inside of our function, we will have a variable named low, set equal to a value of 0. Then we will have a variable named high, set equal to the length of elements minus 1. While low is less than or equal to high, and x is greater than or equal to elements at low, and x is less than or equal to elements at high, we will check if low equals high. If so, we will check if elements at low equals x. In that case, we will return low. Else, we will return -1. Then we need to plug in that formula that we used to find the probe position. This is the formula that we just went over in the conceptual example. Please type it in exactly as you see me typing it here. Then we will check if elements at the position equals x, the element we are searching for. If so, we will return pos, the position of the element in the list. If the element in the list at the position is less than x, the element that we are looking for, then we will set low equal to pos plus 1. Else, we will set high equal to pos minus 1. Then we will return -1, meaning that if all of the code in the function executes without finding the element we are searching for, then our function returns us -1. We are going to run two test cases on our function. The first will call this function on a list of the items 1, 2, 3, and 4, and ask for the position of 2 in the list. When we run the code, you will notice that the first test output 1, since position 1 is where element 2 is in the list. The second test case will use the same list of items and ask for the position of element 5. Note that element 5 does not exist in the list we are passing in. The second test case output -1, since the element 5 was not in the list. In the next lecture, we will learn what sorting is.